morning, children. How are you? It's been a long time. I hope all of you are staying home and staying safe. I hope you're spending quality time with your parents. Help them wherever you can and enjoy yourselves. I thought we will have a small maths class today. The topic for today is pair of linear equations in two variables. Now, if you remember, in class 9 we had a linear equation in two variables and we solved them graphically, and we found that the representation of that line of that equation was a straight line. Okay, so the standard form of that equation was ax plus by plus c equal to 0. This was the standard form of a linear equation in two variables. The two variables being x and y, and c was the constant term. For example, supposing I had 2x plus 3y minus 5 equal to 0. What did we do? We gave values for x. We said let x equal to 0. When x was equal to 0, what did we get? We got 3y is equal to 5. That implies y is equal to 5 by 3. So the value, the point we got was 0, 5 by 3. This was a solution of this equation. Similarly, we said let y equal to 0. If y was equal to 0, then what did we get? 2x minus 5 equal to 0. That implies 2x is equal to 5. That implies x is equal to 5 by 2. So the solution set that we got was 5 by 2, 0. So we got the x coordinate as 0 here and the y value as 5 by 3. And here we got 5 by 2 as the x coordinate and the y coordinate was 0. When we plotted these points, what did we get? We got a straight line. You remember that? Okay. Now, if we are going to talk about a pair of linear equations, that means there are two equations. When there are two equations, how many lines will we get? Naturally, we will get two lines. Yes. So, the standard form of a pair of linear equations is a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, where a1, a2, b1, b2, c1 and c2 are all real numbers. Okay. Now, if these two equations are going to be solved graphically, there will be three conditions that are arising. That is, you will get a pair of lines, right? They can either be intersecting lines. They can be intersecting lines or coincident lines or parallel lines. So, let us see. They can either intersect at a point. Two lines, they intersect at one point, or they can coincide on top of each other like this. Okay, so there is one line first, the next line there is a coinciding line, or they can be parallel. Okay, so this is the first case, this is the second case, and this is the third case. Now, when they intersect at one point, that means the pair of lines will have a unique solution. How many? Unique. That means only one solution. If they coincide, how many common points will they have? They will have infinitely many. So the answers for those two equations will be infinitely many solutions. Infinitely many solutions. Now when they are parallel, there is no common point. So it is understood that it has no solution. Do you understand? So when we have a pair of linear equations and represent them graphically, we get three cases. The first case is intersecting lines. When they are intersecting, how many solutions do we have? We have one and only one solution. If they coincide, there are infinitely many solutions. When they are parallel, there is no solution. Did you understand? Okay. Now let us go to the algebraic interpretation of these lines. Okay. Now when we compare the coefficient of x of this equation and the coefficient of x of this equation, what do we get? We get a1 by a2. When we compare the coefficient of y of this equation and this equation, we get b1 by b2. This is another ratio. When we compare the constant, we get another ratio. Okay. Now, supposing a1 by a2 is not equal to b1 by b2, then we get a unique solution. What do we get? Unique solution. Supposing a1 by a2 is equal to b1 by b2 is equal to c1 by c2, if all the three ratios are equal, then we get infinitely many solutions. Supposing we have a1 by a2 equal to b1 by b2 not equal to c1 by c2, in that case we get parallel lines and no solution is possible. Did you understand? So this we can represent as a table. Okay. Supposing we have the pair of equations to be supposing the equations are a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, then we can represent it like this as a table. First we have the ratio. Next we'll have the geometric representation. Then we'll have the algebraic interpretation. When we have this algebraic interpretation. Now, the ratio that we need can be taken like this. Supposing it is a1 by a2 is not equal to b1 by b2, in that case, the geometric representation will be intersecting lines. Now, when they are intersecting, how many solutions do we get? We get a unique solution or one solution. Right? Then, supposing we have a1 by a2 equal to b1 by b2 equal to c1 by c2. In that case, we get coinciding lines. Coinciding means they overlap. Coinciding lines means how many common points are there? Infinitely many. So we will have infinitely many solutions. Okay. Then last condition will be A1 by A2 equal to B1 by B2 not equal to C1 by C2. In this case, the geometric representation will be parallel lines and there will be no solution for this. Okay. Now, when we have unique solution and infinitely many solutions, the equations are said to be consistent. When they have no solution, we call it inconsistent equations. Okay? So, consistent equations in this case and here inconsistent equations. So, shall we have a recap? If you notice, we are going through the chapter, a pair of linear equations in two variables. Now, the standard form of these equations are a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, where a1, a2, b1, b2 and c1, c2 are all real numbers. Okay? Now, these two equations, when represented graphically, we will get two straight lines. Now, these two straight lines can either be intersecting, coinciding or parallel. Okay? So, when they intersect, we get only one common point and so we get one solution. When they are coinciding or one on top of the other, the number of common points are infinitely many. You know, a line is made up of infinitely many points, right? So when they coincide one on top of the other, there are infinitely many common points and so there are infinitely many solutions. When we have parallel lines, there is nothing common in both. So we get no solution for those two lines. Okay? Now, if we want to get what type of lines they are, we can compare the coefficients of x and y and the constant term to get the result. For example, if I compare a1 by a2 and b1 by b2, if they are not equal, I find that they are intersecting lines with unique solution. And if a1 by a2 equal to b1 by b2 equal to c1 by c2, we get coinciding lines and so infinitely many solutions. Supposing a1 by a2 equal to b1 by b2 not equal to c1 by c2, then the result is parallel lines and no solution. Have you understood? So from the equation itself, we are able to find what type of geometric representation will be there. Understand? Then the equations, if they have an answer, that is either one answer or infinitely many, then they are called consistent equations. If they have no answer, they are called inconsistent equations. Okay, now let us have an example of these equations so that you understand how we get the result. Okay, so supposing I have let us have an example. Say 2x plus 3y minus 6 equal to 0 and 2x plus 5y minus 7 equal to 0. Now, if we compare the coefficients of x and y, what will I get? I will get 2 by 2 and here I'll get 3 by 5. I have taken the coefficient of x and the coefficient of x in the second equation and the coefficient of y and the coefficient of y in this equation, and I find that they are not equal. So what type of lines will they represent? They will represent intersecting lines and they will have a unique solution. Now, supposing we have another pair of equations like this. Say 2x plus 5y minus 1 equal to 0 and 4x plus 10y minus 2 equal to 0. If I compare the coefficients, what do I get? 2 by 4 equal to 5 by 10 equal to minus 1 by minus 2. See, 1 by 2, 1 by 2 and 1 by 2. So, A1 by A2 equal to B1 by B2 equal to C1 by C2. So, what kind of lines will they be? They will be coincident lines and they will have infinitely many solutions. So, this two conditions. Now, the third condition, let us represent by these lines. Just say I have 4x plus 2y minus 6 equal to 0 and I have 8x plus 4y minus 7 equal to 0. Now, if I compare the coefficients, what will I get? 4 by 8 and here 2 by 4 and minus 6 by minus 7. Now, when I cancel, I will get 1 by 2, 1 by 2 and this will be 6 by 7. So, what happens? These two are equal and this is not equal. So, what's the condition I am getting? A1 by A2 equal to B1 by B2 not equal to C1 by C2. So, what kind of lines will they represent? They will represent parallel lines and they will have no solution. Okay, children, I hope you had a nice time. I enjoyed the class also. I hope you also enjoyed the class. Stay home, stay safe.